Hi everybody, welcome to Note 6.4. Today we're going to be talking about multiplying and dividing rational expressions.
So we're going to begin day one with this graphic. It says friends, don't let friends divide by zero. What that means is you can never, ever, never have a zero in the denominator of your rational expression or your fraction. Just like we don't allow zeros in any denominator, it goes for this concept as well. So in this lesson, we're going to be talking about some variable restrictions as well. So just remember, friends, don't let friends divide by zero. Let's look at our first example. They want us to simplify 1 over x all over x plus 2. Or you could say 1 over x divided by x plus 2. Either way, when you see a fraction in either the numerator or the denominator, you want to take it out of this fractional format and you actually want to write it as a division problem. So this is really 1 over x divided by x plus 2. Now, you're probably wondering, where did that 1 come from? Well, remember, if you want a denominator, your denominator is always over 1. So you have that imaginary denominator of divided by 1 in the actual denominator. Because again, dividing by 1 does not change anything. So we write it as 1 over x divided by x plus 2 over 1. Okay, now, depending on who you had for 6th or 7th grade math, you may have heard different versions of this little sing-songy rule. When dividing fractions, don't ask why, flip the second, and multiply. Now, your teacher may have said, when dividing fractions, don't be shy, flip the second and multiply. Both are perfect because ultimately what matters is what comes after the comma. Flip the second and multiply. So what we're going to do is we are going to change that division symbol into a multiplication symbol, and then we're going to flip what comes after the division sign. So it looks like that. We have 1 over x times 1 over x plus 2. Now it's just straight multiplication. Now in this case we cannot factor anything because nothing is factorable, so nothing will cancel out. So if you can't factor it and nothing cancels out, then all you have to do is you have to multiply the top times the top and the bottom times the bottom. So 1 times 1 is 1, and then x times x plus 2 is x squared plus 2x. So when we simplify this problem, it becomes 1 over x squared plus 2x. Now, we can't let you get away without talking about some variable restrictions. Okay, so we have to talk about these variable restrictions. Now remember, you have to look at the denominators. Even if something is canceled, it still has to be considered in the variable restrictions. So now there's one little catch with division. With division, you have to check the original problem, the steps in between, and then the final denominator. So you want to make sure that you check each denominator because no denominator along the way can equal 0. So we start with the original problem. Okay, so right up here, x can't equal 0. So we're going to put 0 there. Then if we look right here, to keep this from going to 0, we also have to include negative 2 because x plus 2 equals 0, we get negative 2. Now, looking along the way, okay, x can't be 0 here, so we've already got this guy right here. We've already got the 0. Okay, here x can't be 0. Okay, so we've got another 0. And then right here, x can't be negative 2. So we've already got that negative 2. Okay? So, and then of course finalize, we just multiplied them together, so we're still dealing with 0 and negative 2. Okay? So when we go to list our variable restrictions, we know that x can't equal negative 2 and 0. Those are our variable restrictions. Now, you may be wondering, well, let's look at that one denominator we really didn't talk about. Let's look at this guy. Why are there no variable restrictions here? Well, there are no variable restrictions in that denominator that is right here because there is no variable. You only have variable restrictions when there is a variable in the denominator. So you don't have to worry about if there's a constant, only if there is a variable. Okay? Let's move on to our next example.
All right, our next example wants us to simplify x squared minus 4 over x squared minus 1 times x plus 1 over x squared plus 2x. This is not division, so we don't have to flip and multiply, but what we do need to do is we need to factor and reduce. So looking at the fraction on the left side of the multiplication symbol, both numerator and denominator are difference of two squares, and looking at the fraction on the right side of the multiplication symbol, only the denominator can be factored, and that's going to be a GCF. So the left side factors to be x plus 2, x minus 2 over x plus 1, x minus 1. The right side factors to be x plus 1 over x times x plus 2. So now we cross out common factors. Now, if you look right here, I see that I have x plus 2 on the top and bottom. It doesn't matter that one is the top left and the other one is the right bottom. It doesn't matter. As long as one factor is on top, one factor is on bottom, they cancel out. Same with the x plus 1s. So now that I've canceled out all common factors, I am going to multiply the results back together. So on top, I have x minus 2, and that becomes x minus 2 over x squared minus x. Now that cannot be simplified any further. Now we're ready to talk about variable restrictions. So if I look at this denominator here, he is the same as this guy. So right away I see that x, because remember it can't be 0, x can't equal negative 1 and it can't equal positive 1. And then if I look at this denominator right here, well, because I didn't flip and multiply, it's the same as that denominator down there. So I also see that x can't be 0 and it can't be negative 2. So when I go to write my variable restrictions, remember, write them in ascending order, so smallest to largest. I write that it is x cannot be equal to negative 2, negative 1, 0, and 1. Let's look at our next example.
Okay, so example 2 says to simplify x squared plus 2x minus 15 over x squared minus 16 divided by x minus 3 over 3x minus 12. Now, before you start factoring, you want to do your little rule. Dividing fractions, don't ask why, flip the second and multiply. Woohoo! We need like a cheerleader. Okay? So the first thing you want to do is you want to flip the second and change it to multiplication. So flip the second fraction, change it to multiplication, and now this is what we did in the last lesson. So the first step is to factor. So I'm going to factor x squared plus 2x minus 15. So two numbers that multiply to make negative 15 and add to make positive 2. Oh, 5 and negative 3. And then down here we have a difference of two squares. So it's going to be an x plus and x minus, and it's going to be x plus 4, x minus 4. Okay, let's look at the next one. Now, this is just a binomial, a linear binomial, so I can't really, the only thing I can factor out of the top right is a 3. So I can take out a GCF of 3, and that leaves x minus 4. And then on the bottom, you cannot factor that. All right, so let's start crossing out things we have in common. What do you see first? Right, we can cross out x minus 3. Do you see anything else? That's right as well, x minus 4. So I look at the remaining factors, nothing else cancels. Now remember, when you're canceling, as long as one's on top, one's on bottom, it doesn't matter if they come from, this one's on the left side of the multiplication, the other one's on the right side. As long as you have one on top, one on bottom, they're safe to cancel out. So again, looking at my factors, I don't see anything else that will cancel out. So I'm going to multiply the remaining tops together and then multiply the remaining bottoms. So here I have 3 times x and 3 times 5. So that gives me 3x plus 15. And then on the bottom, all I have is x plus 4. So we end up with 3x plus 15 over x plus 4 as our final answer. Now, before we go on to the next problem, we have to talk about variable restrictions. That's right, we have to talk about variable restrictions. So, looking at this guy right here, x squared minus 16. Well, we know that factors down to be x plus 4, x minus 4. So that tells me that I cannot have negative 4. I also cannot let it be positive 4. Okay, then let's look at this guy. 3x minus 12. So we set him equal to 0, and I end up with 12 divided by 3, which is positive 4. We already got him right here, so he's good. Now, here, this denominator is the same as that denominator. So we don't need to worry about him. We've already taken care of him. However, this guy down here, he's new. So x minus 3 equals 0. So that tells me that x cannot be 3. And then I look at the final answer, x plus 4. Well, that means x can't be negative 4. So I've already got negative 4 accounted for. So my variable restrictions are x cannot equal negative 4, 3, and 4. Now remember, we like for you to write them in ascending order, so from least to greatest. And then don't forget to put them in your birdie braces, because it's not really solution set, but this is a listing of numbers that x may not equal. So there are your variable restrictions. All right, let's move on. Okay, let's look at our next example. Here, they want us to simplify 1 over 2x cubed minus 16 divided by 1 over x squared plus 2x plus 4. Well, remember, the first step before you do any kind of factoring is dividing fractions. Don't ask why. Flip the second and multiply. Woohoo! Okay, so that is my first step. I have to change it to multiplication, and then I flip what comes after the division sign. Now, you'll notice, Ray, what happened to the left side? Okay, let's look at what happened to the left side. I notice, I'm like, oh my gosh, this is so almost like a difference of cubes, but 2 and 16 aren't cubes. So in going from this step to this step, I went ahead and factored out a 2 because I knew that was coming. So I just kind of killed 2 birds, 1 stone. All right, now we are ready to factor and reduce. So we're going to factor and reduce. Now, in looking at this left rational expression, x cubed minus 8, x cubed minus 8. Well, that looks like a difference of cubes. So if you remember your rule for difference of cubes, it's a minus b times a squared. Bear with me, I'm writing with the computer. A squared, this is minus, so we're going to go plus, and then it's a times b, and then plus b squared. So that is the rule for factoring difference of cubes. So let's look at this. Okay, so what cubed gives me x cubed? Oh, that's easy. That's x. And what cubed gives me 8? Okay, well, that's easy too. That's 2. So your a is x. Sorry, that doesn't very much look like a nice x there, but it is. Okay, so your a is x. I'm going to rewrite that. I do not like that x. There you go. Okay, that's better. Okay, so your a is x, your b is 2. So when you go to factor this, the left side becomes, now don't forget that 2, he's a GCF. So if you had to ever, for whatever reason, multiply this dude back together, you have to have that 2, so don't forget him. But x cubed minus 8, a is x, b is 2. So I just fill in right there, and I get x squared plus x times 2, 2x, 2 squared is 4. And then we hit times and then the numerator. Now let's talk about x squared plus 2x plus 4. Well, first of all, nothing multiplies to make 4 that also adds to make 2. So that's not possible. But remember what we told you when you're factoring sum and difference of cubes? The trinomial part of the rule will never, ever, ever factor. If it does factor, you've done something wrong. So that trinomial part should never, ever, 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 never, ever factor. Okay? So now let's talk about, can we cancel stuff out? Oh my goodness, holy Toledo, Batman, the trinomials cancel, don't they? Those trinomials will cancel. Do you see anything else that cancels? You're probably thinking the ones. And, you know, that wouldn't be illegal if you canceled them out. It's no big deal. But just, you know, even if you cancel them out, there's nothing left in top. So your top ultimately becomes a 1. So it's up to you whether or not you want to cancel out those ones. But in the denominator, I still have 2 times x minus 2. So what I'm going to do is I'm going to take that 2 and distribute it to the x, and that 2 and distribute it to the 2. So that becomes 1 over 2x minus 4. And we're done. Mostly. The next thing we need to figure out is the variable restrictions. Well, let me erase my markings so we can do some new markings here. Woo. Bear with me, I am just erasing what I wrote here so I can have more room to write some more. Okay, so let's look here at our denominators, okay? So 2x cubed minus 16, the left side never, ever, 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 never changes, okay? It never, ever, ever, never, ever changes. So right here, well, 2 won't ever equal 0, so we're fine there. But x minus 2 will equal 0. X minus 2 will equal 0. So that tells me that I cannot have 2. Now, this guy, okay, he won't factor. But if you remember back when we did talk to you guys about factoring and solving sum and difference of cubes, this x squared plus 2x plus 4, which also appears down here, it will never, ever, ever, ever solve to be a real solution. Because if you try to plug that into the quadratic formula, because he doesn't factor, you're going to end up with an imaginary number for an answer. And with variable restrictions, we only want real numbered possibilities for variable restrictions. So you can, if you forget that, you can plug them into the quadratic formula and see what you get, but ultimately you are going to end up with an imaginary answer. So we don't have to consider, okay, we do not have to consider this guy, which is also the same as this guy, okay? So we don't have to consider him in terms of variable restriction because he will produce an imaginary answer. So we already talked about this guy. 1, not a variable, so not going to have a restriction. Same with down here. Now, if we look at the final answer, 2x minus 4, if we set him equal to 0 and solve, we're going to get a 2 again. So it looks like 2 is our only variable restriction. So x cannot equal 2. All right? Let's look at our last problem. All right, let's look at our first example. In this example, they want us to simplify x plus 5 to the negative 1 times x squared plus 9x plus 20 all over 3x plus 12. Well, the first thing I notice here is that this factor has a negative 1 for the exponent. So, since this guy right here, since he is negative in the numerator, we're going to move this whole factor, here to the denominator, and he's going to gain a positive 1 instead of a negative 1. Then what we're also going to want to do is we're going to factor x squared plus 9x plus 20. So two numbers that multiply to make 20 and add to make 9. I'm thinking 5 and 4. And then we will factor this guy. Now this is a linear binomial, so we can only pull out a GCF, and that GCF will be 3. Okay, so move the negative power, factor, and reduce, which is what we just did. So if you look here, I moved x plus 5 to the bottom. So if you look again right here, now you'll notice I moved him to here. And you're probably thinking, well, does he belong in the front? Does he belong? It doesn't matter, okay? It does not matter. I just tacked him on to the end. And then, I apologize if you just heard a cat hiss. That was mine. He's upset about something. So, and then here, x squared plus 9x plus 20, that factored into x plus 4, x plus 5. And then 3x plus 12, I factored the 3 out, and that became 3 times x plus 4. All right, now let's look and see, do we have any common factors on the top and bottom that would cancel out? So take a good look there and see what you find. All right, so let's see. X plus 4, right? What's another pair? X plus 5, exactly. Now, we've canceled out our common factors, and that does not leave us anything on the top except for the understood 1. So that becomes 1/3. I don't know why that 1/3 is so big. It just, when I put it on the slide, it was just ginormous. So anyways, the answer is 1/3. Excellent. Now, we're still doing variable restrictions though. So when I do the variable restrictions, remember you consider the original denominator first. So if I set 3x plus 12 equal to 0, I get x equals negative 4. So I'm going to put that down right here, negative 4. Let me pick a different color so y'all can see that a little bit better. So we said that denominator gets us a negative 4. Now 3, never going to be 0, don't have to worry about it. X plus 4, well, let's see, that'd be negative 4, so we've already got him taken care of there. and x plus 5, well, that means that he can't be negative 5. So that makes my variable restrictions x can't equal negative 5 and negative 4. All right, so let's just review. Let's review those steps real quick. Okay, I'm gonna erase all my markings here. So here we go. The first thing we did was we took this x minus 5 and put them down here on the bottom. Then we factored the top. So we factored this top here, and it became these guys, okay? And then, last but not least, 3x plus 12 got factored, and it was factored into 3 times x plus 4. Then we crossed out our common factors, and that left us with a 1 on top, a 3 on the bottom. Therefore, when we simplify this rational expression, it becomes 1/3. And then we took all of our denominators, set them equal to 0, and that's how we came up with our variable restrictions. All right? Okay, let's look.
Our next example wants us to simplify 8x squared y over x plus 1 all over 6xy cubed over negative x minus 1. Now, whenever you see a fraction within a fraction, the first thing you want to do is rewrite it as a division problem. So it becomes 8x squared y divided by x plus 1 divided by 6xy cubed over negative x times x minus 1. Now you may be wondering, wait a minute, in the original problem, it was negative x minus 1. And you are right. But remember, we want our leading terms to be positive. So what I did is, as I rewrote it as a division problem, I just went ahead and factored out a negative 1 so that it would make my leading term positive. Now, we're going to remember that phrase we learned in school. When dividing fractions, don't ask why, flip the second, and multiply. Woohoo! So we are going to flip the right side and change it to multiplication. Now, we want to factor and reduce. So do I see any common factors that will cancel out? And the answer is yes, x plus 1. Now I know you're probably thinking, well, the x can cancel out with the x squared, the y cubed. Yes, that all cancels. But to make it a little bit easier on the eyes and make it easier to visualize what it's going to look like, before we do that, let's multiply it back together, since that's all we have are x's and y's. We don't have any binomial factors left. So I multiply it back together. I get negative 8 because of the negative 1 on the right. Negative 8x squared y all over 6xy cubed. So the first thing I see is that negative 8 and 6 are going to reduce to negative 4 over 3. X squared over x is going to become x in the numerator. Y over y cubed is going to become y squared in the denominator. So I end up with negative 4x over 3y squared. Now, let's talk about our variable restrictions and how I ended up with negative 1 and 0. Well, if you look back at the original problem, we had a fraction in the numerator. Well, the denominator of that fraction was x plus 1. So I said x plus 1 equal to 0, and I got x is negative 1. Now, if you look at the fraction that's in the bottom, the fraction in the bottom has a denominator of negative x minus 1. So when you set that equal to 0, you end up with negative 1 again. Now, the next one you have to consider is the numerator of the fraction that's in the denominator. Because if this numerator went to 0, it would make the whole fraction go to 0, which would put a 0 in the denominator of the overall fraction. So we can't let the numerator of the denominator ever equal 0, because 0 over anything becomes 0, which puts a 0 in the overall denominator. So I have an x, so I'm like, well, x can't be 0. Awesome. So that's how we get the 0. But we also see that y cannot be 0, because if y was 0, it would make that numerator 0 as well. All right? So that concludes this example. Let's go on to our next problem.
All right, let's look at our last example. They want us to simplify 2 over x plus 5 divided by 3 over y minus 1. Now, essentially, what this is an example where we have two rational expressions inside a rational expression. Okay, so this is not going to be as simple as writing as the division problem, flipping the second, and then multiplying. What we have to do is we have to find the LCD, okay? We have to find the LCD of the numerator and denominator. So we want the LCD of the entire problem, okay? So what we're going to do is we are going to take and we're going to say, okay, this denominator is x. This denominator, well, he's 1. This denominator is y. And this denominator is 1. So think back to your early days of learning fractions. Let's say you had two denominators of 7 and 5. Well, you might not have recognized the common denominator there. So your teacher taught you, well, if there's no evident common denominator, then that's 7. We multiply them together and we get 7 times 5. Now later on you'd go, oh, 7, 14, 21, 28, 35. Okay, 5 and goes into 35. But a quicker way to do that was just to simply multiply the two denominators together, or however many you had. So in this case, that's what we're going to do, because there will be no common multiple. So we are going to multiply x times y and get a common denominator of x times y, which is xy. Now, what we're going to do is we're going to multiply every piece of this expression by xy. And you're like, but I don't understand why we're doing that. Here's why we're doing that. Because when we multiply each piece of this expression by the common denominator, it's going to be doing what we call clearing the fractions. So that will get the fraction out of the numerator. It'll get the fraction out of the denominator. So I'm going to take and I'm going to multiply 2 over x times xy. And then I'm going to multiply 5 by xy. Then I'm going to multiply 3 over y by xy, and then I'm going to multiply 1 by xy, so that it looks like this. Now, here is the cool thing about why we do this, because look what's going to happen. Here, 2 over x, okay, so right here, this x cancels out with that x, and then nothing cancels here. Here, this y cancels with this y, because xy is in the numerator, if you think about it like that. So then what I'm left with after I do that is 2y plus 5xy all over 3x minus xy. Now, that's your final answer. That's as simplified as you get. Now, when we get into the adding and subtracting, I am going to show you another way that you can tackle that, but I want you to try to master this method first, and then, like I said, I will show you the second method of how to simplify a problem like this when we get to adding and subtracting. okay? So, but for right now, I want you to learn this way. Now, the next thing we need to talk about is our variable restrictions. So, we want to talk about those variable restrictions, the places that the values that the denominators equal, or excuse me, that they can equal to keep your denominator from going to 0. So if I look right here, I have x. So right away that tells me x cannot be 0. That's supposed to be 0. Okay, go with it. All right, so then he's got a denominator of 1, no variable. We're cool there. And then this guy, well, I know y can't be 0 because that would make that fraction have a 0 in the denominator. Now, where you want to look, okay, so yeah, we know y can't be 0 because we don't want this denominator to go to 0. But what you also want to check is you want to check and find the value that would make this entire, because this is still the denominator. You want to make find the value that would make that entire denominator go to 0. So what I do is I do 3 over y minus 1, and I set it equal to 0, just like I would do to any other denominator. I add 1, so I get 3 over y equals 1. Now, he doesn't have the denominator, but I can put him over 1 without changing his value. And then I cross multiply, and I find out, well, hey, y also cannot equal 3. Because look here, if y was 3 right here, this would give me 3 over 3, which is 1. 1 minus 1 is 0. So that's how we figure out the variable restrictions. So we get that x cannot be 0 and y cannot be 0 or 3. All right, let's move to our next slide.
All right, our last slide is this one. This is a happy pre-AP IB Algebra 2 student doing his homework. So I just wanted to show you guys this because I thought it was a cute picture that my friend sent me of a teddy bear, big, huge, ginormous teddy bear, sitting in a desk doing his math homework. So just wanted to give you guys a giggle and help you understand there's fun in math too. So anyways, I hope everybody has a great day. Please remember social distance of 6 feet. Wash those hands. Wear your masks because the quicker we get through this, the quicker we can return back to our daily normal activities. Have a good one, y'all. We'll talk to you next time.